the top formula, and you see that when you project onto x, you get a wave function. This here is psi star I of x. It's the complex conjugate of the wave function of the ith energy level. The ith energy level has a wave function. This is its complex conjugate. The wave function itself would have the opposite order. What about this state here? That's a state with one particle in the ith energy level. So I'm going to write it this way. I'm going to take a creation operator for making a particle in the ith energy, and I'm multiplying it by the vacuum. I've created one particle in the state I by applying the creation operator on the vacuum, and that's exactly the state here. On the other hand, this is just a complex conjugate of the wave function, and my rule is sum. Did I erase the definition? No, there's the definition of the field operator. Okay, go to the second row. Psi star, the field operator, is sum over I, a plus of I, times the complex conjugate of the wave function. That's exactly what you see here, right? So this is exactly equal to the field operator at position x on the vacuum. That gives us a new interpretation of psi. It's the operator which creates out of the vacuum a particle at position I. I think that's a fairly intuitive thing, that it's a quantum operator at position x. Sorry. Good. So the AIs create particles with certain energy levels. The psi creates particles at certain locations. It's also a kind of creation operator. The field operator itself is a kind of creation operator, but instead of creating a particle with an energy, with a definite energy, it creates a particle with a definite position. Here? Yeah. It should be dagger. Good. You never use star for operators. Dagger. Good. No. Yeah, wave functions are numbers. They're numbers. They're not. They're trivial operators. They're numbers. Sometimes ordinary numbers are called C numbers. This is another invention of Dirac. C stands for classical. There's classical numbers. Operators are called Q numbers for quantum. Q numbers don't always commute. C numbers always commute with themselves, but they also commute with everything else because they're just numbers. Okay. So now we have a lovely new interpretation of the field operator. It's the creation operator for a particle at a point of space. Let's look at some interesting quantities. I think with, we can put this up. Just to get a little more experience with this, let's play with it a little bit. Here's an interesting... Here's an interesting quantity, integral dx. The operator psi dagger of x times psi of x. Now, is this the same thing as up on the top of the blackboard up there? Dx psi star of x, psi of x? No, it's not the same thing. It looks very similar, but it's not the same thing. In the top formulas up on top. The size is just wave functions, one particle wave functions. They're not operators. And the right-hand side is just 1 by total probability. This object here is an operator. Psi is an operator. Psi dagger is an operator. When it acts on a state, it does something. This one creates a particle. This one annihilates a particle. So, but nevertheless, it has some formal structural similarity with the thing up on top. One wonders, what is it? Does it have some meaning? Is it something that has a physical significance? Is it something that you can measure? Incidentally, it's Hermitian, because if you take any operator and multiply it by its Hermitian conjugate, the result is Hermitian. That's like multiplying a complex number by its complex conjugate. The result is always real. Okay, so let's see if we can figure out what this thing is. First step, let's replace the size by their definitions. So this is integral dx, and now psi star, that's a sum over I. It's going to get messy, but then it'll get easy. AI dagger, AI plus, times psi star I of x. Without the what? Without the which? No, that's right. Now I'm going to write the psi. That has another separate sum. It's not the sum over the same I. It's a sum over a different I. But I can just call it J. It's a double sum. There's a double sum here. And the double sum has AJ psi J of x. It looks a bit complicated. An integral over x of a double sum over I and j, plus the fact that the integral is over all space and I and j go from 1 to infinity. So if you were actually to calculate it, to put it on your computer would run forever and ever and ever and ever and would never halt. However, we can do better than that. Let's do the integral over x first. Now, I think we have a formula here. Psi I of x. There it is.